motto is power for today and a world for tomorrow.
And our idea is tidal buoy turbine generator.
Our product is a tidal generator that runs by using a cable attached to the sea floor. This cable will be attached to a mechanism that both recoils and is attached to a transmission that will convert the high torque of the tides to a high speed force so it can be delivered at a viable speed for the generator. So it has some environmental advantages over other tidal generators that are in current use.
Move forward. Yeah, so then there's the tidal stream generator, which works by the movement of tidal streams. They're usually very tall, destroy the entire ecosystem around it. They have giant spinning blades, which mess with the fish environments. This is an example.
Kind of looks like a wind turbine, but like for water.
And it has a ridiculous torque compared to the wind turbine.
So yeah, a tidal barge generator. It just is pretty much like a dam almost. So it just destroys both living organisms on land because it floods some of the areas, and in the water because it takes up a large area of the seafloor where some fish could breed or could have habitats.
Also, the problem with the tide generators is when these things open up and close, the fish that go through get demolished because it's going through a turbine. So a lot of fish get caught in the currents going down through and out of the barge, and the fish die. So it's bad for the ecosystem.
Give me that microphone in there, Tori.
The last type is a hydrofoil pulse generator, and it is the least harmful of the existing tidal generators, yet it still poses danger to marine life because it has a blade that moves up and down, and this blade could make contact with both fish and the seafloor at times.
This is the current, this is an existing technology, right?
Yeah,
These are existing technologies.
The tip here changes like this, so the water pushes it down, and then it switches like this, so the water pushes up, moving this axle, which moves the piston and generates the energy.
And it also takes up a lot of area on the seafloor to get a large enough swing arm to produce enough energy. So some of the mechanics of our idea.
Okay, so basically, like one of the focal points that we focused on for our idea is like minimalistic damage to our the environment. Like it takes up barely any like space on the sea floor, and yeah, it's just minimalistic. That's what we kind of focused on.
Yeah, this slide talks about the fact that the string that holds the buoy tip down will work like an anchor on the seafloor, and the height, because this buoy is not, the tide doesn't move very fast, but it has a ridiculous force. We're going to use a large amount of gears in our generator to create the speed required to maximum energy.
So increasing the number of gears will increase the speed?
Actually lowering the gear ratio will increase the speed from high torque to high speed.
So the generator will take advantages of areas with large tides like the Bay of Fundy, which is in the Maritimes in Canada. And it has a tide of 53.3 feet. And this will actually go up and down 3 times a day. So this will produce large amounts of energy.
That's about.
What are the changes in?
So you have a 53.3 up, then you have 106.6 down, and then you have 106.6 up, and then you have 53.3 down. Meaning together you have
Like for example,
157.1.
this is part of the Bay of Fundy, and as you can
upwards.
see, you can actually see the sea floor.
That's all
when it's
land.
out.
That's all land until like that blue line right there, and it changes all the way up to blue.
And up to where those rocks are, that becomes completely dry land.
wetland.
And then when the tide comes in, it floods it all. So,
Okay, so there's three main parts to our system. There's a recoiling device, which gets rid of slack when the tide's going back down. Okay, make a moment.
and this recoiling device will be similar to a rowing machine.
Yeah. Yeah, it's like the same one you find like on a rowing
It
machine.
would be similar to this part here, because as you pull the rowing machine out, when you're coming back in, it recoils and still keeps the spinning motion of the fan.
Yeah.
So it works the same.
Second, we have like a high-speed transmission box, which gets it's usually a slow movement and turns into a fast speed for the generator.
It's basically our low to high gear ratio.
It would work kind of the same as a car transmission, but the opposite. Because a car transmission goes from a very high speed with very low torque to a very high torque with possibly a little bit of a lower speed.
So we're pretty much going to reverse that.
The torque conversion for pulling trailers and stuff.
So here's just basically like if you zoom out what our thing would look like. Basically like we can convert a buoy just by replacing the anchor with a generator. We have fail-safe hooks. We a 20-meter buoy.
Any kind of way.
Go to the next one. Alright, here's the inside. So basically, when the tide goes up, it pulls.
Use the
Mark and blue black line.
Well, basically, when this is kind of wrapped around here, when the tide goes up, it unwinds this. It goes to the recoiling device, so it gets tension into the gearbox and straight into the generator. Okay.
And then when the tide's coming back down, that recoiling device.
All the tension it gathered will recoil it back down. So resetting it. So like this is a form of free energy. So like once you set it up, you don't have to do anything. It'll constantly be resetting itself, and just produce like
so I came up with a formula that this wasn't in the Bay Thunder. This was actually for Miami, which we have a vertical tide every day of around. We have a 1 meter increase here and then a 2 meter increase here. So every day we had about a 3 meter increase in tide, and then I used the formula for acceleration due to gravity, which was 9.8 meters per second. Then I also used meters per second squared. Then I also used the radius of the buoy, which was a variable that I used because we haven't decided on what radius the buoy may be, because there may be regulations for wildlife, and also the different buoys mean different things for marines, like
Okay,
for people driving
The
boats.
larger the buoy, the more torque we can produce, and the more torque, the more power we can
Yeah,
make.
this was in watts.
with the red marker, go ahead and put the formula that you used.
Well, I haven't finished the.
That's a function, right?
Yeah, but I haven't finished everything.
The horizontal axis is the size of
The horizontal axis is the radius in meters of the buoy.
Okay.
The vertical axis is the amount of energy producing watts per second.
Okay, so go ahead and relate those two with the formula.
Well, I have to finish. There's 84,600 seconds in a day, and also there is for the volume of the buoy.
Right.
And my variable was 4/3 pi r cubed.
So it's a spherical buoy.
So it's a spherical buoy, yeah. And also this is meters cubed. And then the weight of 1 cubic meter of water is 1,000 kilograms, which is equivalent to 1 ton. So the equation for the final force would have been will be 1,000 times 9.8 times. Well, this variable can change. Like for the Bay of Fundy, we would have something more like 30, but for in Miami, we would only have 3. So if we did this in the Bay of Fundy, we would have 215 kilowatts of electricity per second. But this is only in the Bay of Fundy, so this is only in Miami. So
It varies
I
with
use
both
3 meters movement.
location and size of the buoy.
Yeah, but the equation I only have 2 variable equation. So 4/3 pi
takes like 60 watts to like power a laptop. So this is like a lot of power it's producing.
Yeah, we calculated this would power about 10,000 houses if it was a 15-meter radius buoy. So, yeah, at 30 meters in radius, we could produce 21,500 watts, which is enough to power about 10 houses. Alright, 10, I know, 100 houses.
So like a block.
10,000 houses. So it's pretty powerful, I mean. And then this ends, I think. Yeah, this ends. So can you close it on there? Close it there. And escape or whatever. Or just go to the inventor. So I have the. Let me stand here. I have the inventor file for the beginning of the buoy. Here is the buoy. This is only a 1.8 meter buoy, so it's not as big as I wanted, but this is just to show perspective for a small scale. The buoy's line is attached to a coil here. The coil goes around, if you can, that doesn't want to work right now. But yeah, the coil wraps around here and is latched onto the actual spring with a metal band that is connected to a gear. This gear is attached to, I don't know why this spring number wants to show up. Alright, well, it doesn't want to always show up, but there is a spring here, so when the actual gear spins, it tightens the spring, and when this, to keep tension, and when the gear goes back down, or when the tie goes back down, releasing the tension, the coil will release the tension and recoil the actual spring. And then this actual gear will be connected to a transmission, which would then be connected to the generator.
Like we don't just have like a broad idea, like we actually like planned out how we could actually build it, like mechanically.
Yeah, I can tell. Yeah.
So like we can like put this into practice.
What about
Unlike
the
a-
material?
Yes, we were conversing
Yeah,
about
we
the
were-
material. This will have to be surrounded in a box because it will be something that you can do with an everyday average buoy. Was the idea that we just take the rope from an everyday average buoy and throw it into this box,
Right.
and it will work for us. So what we did is we said that the material in this has to be cheap as possible, and also has to be environmentally friendly.
And
So
it
the-
also has to be able to withstand the corrosive aspects of
Yeah,
salt
like
water.
coral can build up on it and block the rope, so we're thinking of that too.
Right.
Yeah.
Like
Like wildlife.
yeah, wild
I mean,
too.
sea life, right?
See that? Yeah. So it has to be big enough so no fish, like a shark, tries to eat
And
it.
like some people like would put lead paint, but that breaks like what we're trying to do by trying to make it environmentally friendly.
Right.
So we're trying to think of different ways of doing
Many-
like using different plastics.
Many
or
high power
styrofoams.
generators use lead paint to prevent the growing of sea plants on it. However, lead paint is actually very bad for the ecosystem because lead drains into the.
And you had mentioned something interesting yesterday, Mitch, about the types of plastics that are out there now for
Yeah.
boats and all that.
Oh, yes.
Can you talk a little bit about that?
There's a very, very strong plastic that they're using for beginner boats right now, beginner sailboats and some motorboats. It's very lightweight, yet it's incredibly strong, and it's cheap and to make and manufacture. And it's also very easy to put into a mold to get the shape you want.
Right.
So that could be applicable to this because it would reduce the cost of the actual generator. It would also be very durable against sea life and salt water because it has no metal on the outside, and this box would prevent the gears from rusting.
Okay.
Yeah. I was going to use grill gears instead of these gears inside of that.
Okay. Questions from the audience? This is an extremely impressive presentation. This is one of the best presentations I've seen.
I have questions.
It's extremely impressive, guys, and this is along the caliber of a presentation that the upperclassmen in the more advanced engineering classes would do. So I'm very impressed with it. Secondly, it's obvious that you guys did a lot of research you know exactly where you're going with this. And you need to make a serious decision, whether or not you guys wanna continue with this for the comrades, okay? I mean, because this is something that I can imagine this being, you know, a strong possibility for this to make it, you know, at
Anything that can power 10,000 houses should, I mean, like.
Yeah. It's very, very impressive.
And this is like innovative, like there's nothing like this, like.
Right, this is
Yeah.
something
This is
that
the
you
first.
just can't
The nearest thing we actually showed the patterns, the patterns. The nearest thing that was similar to this was similar to like a dock, which had two vertical axes and it had a barge in the middle, and this would move a gear across something like this, and then the tide. These were all wooden, so it was not very useful, and it could only be used near land because these had to be touched
These
before.
and shadow water.
And
You
when-
needed to put two pylons into the ground.
Yeah, and then when the water level rose, this would rise, turning these gears, which were connected to a similar generator, turning the shaft.
The other thing I'm using
Excuse me. Zane, go ahead.
So, are you planning on putting these like close to shore or offshore?
Whoever
We're gonna convert pre-existing buoys, like buoys that are outside like docks and stuff, like guiding people in.
Okay,
And like also like weather buoys are like fairly far out.
Like we can like self-power weather buoys, so like you don't have to come and like power them. They can like power themselves now.
And the most beautiful thing about this is that you put it in and you don't even touch it.
Yeah, it's
It
free.
runs
It's
stuff.
free energy. Once you install it, you
But
just get
what
constant.
happens? How are you getting the energy? Like, I understand how you're getting the energy, but how are you getting it back to land to be used?
It'd be like
Oh,
any other.
well then we have wire. We were planning this out. We have wires going to a giant surge breaker, which like have multiple wires come in from other buoys. And then from that surge breaker, we have underwater cables going back to land, which goes to a central like storage unit.
That's the only part that's a little, is the cost, right?
Oh, underwater wiring is not expensive.
That's the generator.
So, but wasn't your idea to try and move down on the amount of space that you're using on the ocean? But if you put this large generator in the middle, isn't that just
Well, think
being the
about
same as all the other ones?
the
generator
previous
was
Not
not
like the
ones.
surge breaker's
Some
like
of-
that big. I mean,
Some of the previous tidal generators have been like 9 meters by like 9 meters and like 21 meters tall, the turbines. And that would just kill everything around them. Plus you would need the exact same cabling on the sea floor to get it back.
Yes.
What will you power with this energy?
What will we power?
Yeah.
Well, there's two types of ideas that I had. One would be if we actually created a farm, actually making farms to use this power to return to the grid, and another could be for self-use, like
Maybe
buoys that needed to be lighted up, or for lighthouses that are like such thing as like Fowey Lighthouse. We could have one outside of Fowey Lighthouse powering the light outside of Fowey.
or like charge boats at a dock or something like that.
Like
And,
you could plug into your mooring buoy so you could get electricity out of it.
And we actually thought of, because we were only really creating the generator, a person could actually throw this off their boat and create energy while they're at dock.
Oh, wow.
Yeah,
It'd be like an at anchor, like
Yeah.
Yeah.
instead of running your generator, just have that throw it off the
Yeah,
side.
that's what we said. We could connect to the because I wanted
Yeah,
to
we're gonna
change
design it
the
like
actual rope to inside the generator being a chain so that I could have a link connecting it. Because I learned about the animation, it won't let me animate the rope.
No?
It won't let you animate a fluid objects. I'll have to make separate chain links, and all the chain links will have to have their own times and changes of angles and movement, which was going to be hard. But I think I might be able to do it. And so yeah, it would have to be a chain that then connects to a rope. So anytime you could put anything connected to this, like you could put a chain from a boat anchor and just throw this off as if it was the anchor,
Right.
and then have your boat moving up and down and powering your own generator.
Yeah, we want to design it sturdy like that, so like you can literally just throw it off your boat and it would work. Like,
Wow.
That's
That
why
would be
this
very good.
hard
Throwing
plastic works.
throwing the plastic boats off the balcony.
Yes.
For the like the self power, like you said, you can use it to self power a buoy or like Bowie Light. Wouldn't it be more logical just to use solar power so you don't actually have to wait the long amount
solar
of time?
power
for
doesn't
time?
generate enough electricity. Like, Plus
you
generates
need
anything.
For a little
and
buoy to
solar
power its own.
panels also are expensive. The average cost of solar panels is
But
like
you're going
They're
to
expensive.
And
Surface
there's no surface area on a buoy, like you can't really
Yeah.
put that many solar panels.
Plus, there's also it takes up a lot of surface area, and solar panels could be fragile, and you can't really like walk all over your boat and just glue solar panels to it.
we calculated.
That's not innovative either. I mean, like,
I calculated that it takes for the amount of energy that we would be producing, it would have taken about like $10,000 with solar panels to create the same amount
But
of
for
energy.
this, don't you have to wait for the tide to keep coming back in
No.
before you can get more energy?
You have to remember it can go up and down.
Oh,
up to
but
like
when I
3
had
or
this,
4
I
times
had
a day.
this as a constant day. I had the watts created throughout the day. If I just did a joule, so we have to multiply by 48,600, then you get the amount of joules, and then that would give you the entire day. But I divided the entire time, because I did 3 meters throughout a day's time frame, right? So what I did is I divided by 48,600, which how many seconds is in a day, which is actually what a watt is. So I calculated that that's how many watts you get throughout the entire day constantly.
tides are always going up and down. They're never like stopped.
Yeah, slack tide. They stop for like an hour.
There is such thing as slack tide.
Slack tides.
What happens on slack tide? What's your thing?
Slack tide is because the coil is actually keeping tension. The generator isn't creating energy during slack tide. However,
Even if a wave came and hit
yeah,
it, it would still
if
generate
a wave
a
came
little
and
bit
hit
of
it, it would still generate electricity. So this is minorly, yes, a wave generator, but mainly a tidal generator.
Is it powered by like the current going through it or going up and down?
Up and down.
Up and
But it can go both ways. So
Like you know how there was
there's
actually
big waves that could do the same.
there was actually well, do you remember how we found that picture of the boat just laying and then like 30 feet up? There was a picture of a boat laying on the surface of the floor in the Bay of Fundy. There was a photograph of a boat laying on the floor of the Bay of Fundy and the tide coming in and the boat being 30 feet above. So that force that moved that boat 30 feet higher would be the force that we're generating.
And like, for example, at my cottage, we have a cradle on the floor of the river, and then when the tide goes out, the boat rests on the cradle, and it's a big boat, so it's a lot of force to lift a boat that size.
Yeah, it can look like tons of weight. Like we're just trying to convert that like huge like amount of energy into electrical energy. And that's what we pretty much built.
Our largest expense is going to have to be the steel for the gears and also the magnets for the only limitation to our thing for time would be the magnets on the generator, on the actual generator, the AC generator where it passes the magnets, the only and that time frame would be 20 years for the ones that they have out in the market.
Okay,
So
question.
it would last around 20 years.
You referred to like having a bigger buoy. How is having a bigger buoy like change anything? Like,
Well,
does this
Think
same
about
buoy-
buoyancy of a boat or something.
Yeah,
Yeah, but it's still pulling on the generator to the
Well,
same
no,
amount.
it's like-
Let him
more-
finish his point. Go ahead, man.
you change the gear train. Like
Yeah.
you can create a stronger and stronger gear train, but it's harder and harder to pull. But it speeds it up faster.
So the more
So-
buoyancy you have, the larger.
The harder gear train we can
Yeah.
make, and the more speed you can get.
So it can gear change on its own.
It would be
No,
variable
no,
to the
just-
size of buoy.
Yeah, you'd have if you
Oh,
had
yeah, set.
if
That'd
you
be
had a
cool.
10 if you had a 10 meter buoy, you'd have a 10-meter box for us. We're only creating a standard.
It's called
Seventy
called
two
simple
meter.
transmission. It
Okay.
can't change.
Will that be affected in places like Miami where the tide's just a couple feet? Or it just changes a couple feet?
Well,
like twice
Well,
a
that
day?
last one was.
The calculation that we
Yeah, the
had
calculation that we showed you was for 3 feet. Of
was
force.
for 3 meters. Well,
It's
for 1
actually
meter
4
tied up
Miami.
and then 2 meters tied up later.
And that would
But
power
the tide change
10,000.
here is only like 1 or 2 feet.
Yeah, it's it can go up to 3.
The 3 meter would power 10,000.
Yeah, and I'm also calculating waves, and it does more than just that. It also kind of
For the waves, like you said, like during slack tide, it would be able to do it for waves. But if you're keeping constant tension on the coil, how is it going to be able to rise and fall so quickly with the waves without losing all the stored energy it already has in the tension?
well, we're not
It
keeping
wouldn't.
we're not keeping tension like to store energy. The tension's on a coil.
The coil that's holding the buoy, though, right?
Yeah.
Let me go back to the picture to make sure.
Yeah.
It works
Here.
the same way as a rowing machine. Think of when you pull a rowing machine.
Yeah, if you gave a
So
rowing
it's
machine
completely slack
When
when
you can hold it out,
Yeah.
and then like a week later you can let it go, and it'll still go back in.
and the thing is rowing machine, you could pull it all the way out, and then here you could just go like that, and it would still generate electricity. I mean, it's not gonna do the whole thing like that, but like if you have ever had the fan rowing machines, when you pull them all the way out, you have a huge amount of energy created by the fan, and then you can just do this and power the fan, but it's gonna be hard. So it's gonna be mostly tidal generator, but the vertical movement of the waves will also generate it.
Okay, Alt P. Very good presentation.
Alt P?
guys.
Wait, I got
Alt P.
I have something
Alt,
on my
Alt P.